All right, this is Mr. Jern, and I'm going to talk to you about velocity versus time graphs. Now, before we talk about the velocity versus time graphs, we had to talk about velocity. So a quick review here. Velocity is just a change in position over time. In other words, where were you, where are you, and how long did it take you to make that change? It doesn't matter if you went a straight line from point A to point B. It doesn't matter if you went a complete zigzag and took you forever to get from point A to point B. It's just where are you, where were you, and how long did it take you to make that change? The change in position over time. That's velocity, okay? And the direction obviously matters there. This change can be graphed. This is what we call a position versus time graph, or a PT graph. Okay, sometimes you'll see it referred to as a displacement versus time graph, or a DT graph, because displacement is just that change in position, okay? Your position is X, X marks the spot type of thing. And so your displacement is just your X where you are, your X where you were. That's what that little zero means, your initial or not position. And you just subtract where you are from where you were from where you are, and that's your position. So sometimes you'll see this called displacement time graph, DT graph. It's the same exact thing. So remember that the slope of a position time graph is the numerical value of the change in position versus time. Okay, that's a lot. It's a big thing. It's called velocity, all right? And so velocity, remember, is not just one single unit. It's not a fundamental unit. It's made up of two different units. That's why it takes a couple seconds to say this. The slope, which is the velocity of a position time graph, it's the numerical value of the change in position versus time. It's that whole change in position versus time, which makes this kind of special. So to kind of keep going with that, the slope can be positive or negative or zero, because you could have a flat slope, in which case you're not changing your position. The velocity is zero, the slope is zero. Or it can be positive or negative, which tells you something about the direction that the object is moving. To summarize all this, basically the slope of a position time graph tells you two things. It tells you velocity, which is two things: the speed and the direction, okay? Velocity is speed and direction. Boom, done. Okay, so let's compare some position time graphs and talk about them really quick. We've got two right here. Now, looking at them, you got to ask yourself two questions. What direction are they moving? And what is their speed like? What's happening with their speed? So I hope you look at these and you could tell me the direction is positive because they're sloping upward. They have a positive slope. And hopefully you could tell me which one of these is the faster one. Which one is faster? Well, of the two, the second one here is the faster one because it's got a steeper slope, a higher numbered slope, which means a higher number velocity, okay, a higher number speed. But then we have two other PT graphs, and these are sloping differently. They look a little bit different. So what's the difference? Well, again, what's the two questions? What direction are they moving? And what's happening with their speed? So in this case, they're moving negatively. They have a negative slope. When you calculate the slope here, you're going to get a negative number. And again, that tells you something about the direction that they're moving. They're moving negatively. Which one's moving negatively faster? Or faster negatively? Which one's moving faster, period? Well, the one with the steeper slope still, because when you figure this out, when you actually do the calculations, you're going to find that even though it's negative, the number is larger, the magnitude is larger. And so that means this one is moving faster because it's steeper. So let's take a look at one more, or a couple more. So then there's this one. That's different. What's going on here? Well, the fact is, you still look and try to answer the same questions. What's the direction and what's going on with the speed? Okay, the direction is pretty straightforward. It's still pointing upward, but the speed thing might be a little bit more difficult, or at least it's not as apparent as these other ones. Because what's happening? Well, we don't have a constant velocity anymore. This is changing. So what's going on? Well, if we look, the slope at the beginning is kind of shallow, and then the slope gets steeper as it goes on. And remember, when we have a smaller or shallow slope, that means slow. When we have a steeper slope, that means faster. So what's happening is this one is moving in the positive direction and it's speeding up. It's getting faster because starts out slow, a low slope, and it ends high with a fast or high slope, fast speed. Okay, what about this one? Two questions. What direction is it moving? And what's going on with the speed? Well, hopefully you got the direction correct in that it's moving negatively. Be careful about saying backwards, because if you think about it, you can move in the opposite direction and you could turn around and move forward. You can move backwards. I could be walking in the positive direction, but I could be turning my back towards you and moving backwards. So backward, forward is a little bit imprecise. So we're going to stick now for the fact that just the word positive or negative. It's moving in the negative direction compared to something else. We don't know what it is. But what is it doing with its speed is the other question. Well, it's still starting with a shallow slope, small slope, and it ends with a steeper slope. So if you guessed that it's speeding up, you'd be correct. Not guessed. Hopefully you were able to surmise that it's speeding up because of the slope change. What about this one? What direction and what's going on with the speed? So hopefully you got the direction is negative, again, because it's sloping downward. And what's going on with its speed? Well, it starts with a steep slope and it ends with a shallow slope. So it's starting out fast and ending out slow. And so it's slowing down, going negatively, moving in the negative direction. Then we got this final one I want to show you right now. Two questions. What direction is it moving? And what's going on with its speed? Well, it's slanting upward. The slope is sloping upward, so it's moving in the positive direction. In this case, it starts kind of steep and it ends kind of shallow, which means that it's slowing down. It starts fast and ends slow. So watch out for that. So those are your position time graph when it comes to velocity. In the top four, there's no change. It's constant velocity, uniform motion. In these bottom four, something's happening. It's speeding up or slowing down. So we need to address that, because now let's look a little bit closer at this slope here. We have a changing velocity. Now finding slope isn't very useful because the slope is constantly changing. In this case, it starts out pretty steep and it ends out pretty shallow. So finding slope is pointless. We could, I guess, find the average velocity, but what good is that going to do us? Maybe you want to do that, but that's not going to help us. So what we can do is find the slope of the tangent at any given point, and we can know the speed there. So at point A, if we treat it like a curve, we could just find the slope of the tangent of the line at that point. So we could find the slope of this blue line right here, and we would know the speed at that point. That's just that easy. I mean, finding tangent. We can do the same thing at point B, and you can see already the slope is decreasing. In other words, it's slowing down. But we can know the speed right there. That's fine. We could find the slope of the tangent right there. Then we can do the same thing at point C, and you can see the slope once again gets shallower. It's continuing to slow down. And point D and point C, and we can figure out all the slopes at any given point just by finding the tangent at those points. And we can know the speed there. Cool, but what good does it do us? Why do we need to know that? Well, we can then record how these velocities change and then graph that compared to time, because time is still happening, right? So if we know the speed at this time, and then we know the speed at this time, and then we know the speed at this time, and then we know the speed at this time, and we know a bunch of different speeds, that's something we can graph. We could graph the relationship between those two variables. So let's do that. But now, instead of a position time graph, it's not a position time graph, because what are we graphing? We're graphing the speed, or we know what, not just speed though, because we know these are positive. These particular ones are positive. Okay, so we know the direction too. So we're not just graphing speed versus time. We're going to be graphing velocity versus time. So let's take a look at that. Here is a velocity versus time graph. Okay. Believe it or not, well, we'll get there in a second. This graph is showing how the velocity changes over time. Okay, velocity starts out kind of starts out kind of large, and velocity as time passes gets kind of smaller, and in fact it gets down to 0. Okay, so believe it or not, this is the same story as this previous graph here, where it starts out fast and it's moving in the positive direction, and it ends up going slow. Like, you might not believe me right now about the whole direction thing, but we're going to get to that later. It doesn't really matter at this point, or it does, but we'll get there. I do want to say that this change of velocity over time, this is what's called acceleration. Okay, it's not just, again, it's not just how much the speed changes, because you could speed up, slow down, speed up, slow down. It's what happened with the speed at the beginning, what happened to the speed at the end, how long did it take you to change that speed or that velocity, and that's acceleration. So acceleration is it has to incorporate the time it took to change the velocity. So this slope, or the change in velocity over time, is called acceleration. And just like finding slope of a position time graph gives us velocity, finding the slope of a velocity time graph gives us acceleration. And it can be 0, positive, or negative. Okay. In this case, it's a negative slope, meaning we have a negative acceleration. Okay. Which in this particular instance means it's going to slow down. Now, that doesn't always mean it's going to slow down if we have a negative acceleration. In fact, we're going to look into that. Okay. So based on that, the question we can ask is this: how does the direction of acceleration affect the velocity of an object? Okay. So you have a little bit of an introduction here, and now we're going to do something to look into that.